हेलो, मैं ऑडिबल?
Yes, ma'am.
स्क्रीन दिख रहा है आपको?
Yes, ma'am.
Yes, ma'am. Visible.
Yes, ma'am.
करते तो मुझे what we studied, we will revise the things in 5 minutes. Let's start with the we are into boiler. So boiler is a heat transfer unit operation. Objective is steam generation. We studied the ISA flow sheet symbol. We studied the types of boiler. There is fire tube and water tube boiler, and there are different criteria also. According to that, there is vertical, horizontal, externally fired, internally fired, stationary, or locomotive boiler. Then we studied fire tube boiler in detail, that is the construction and working of fire tube boiler. Similarly, we studied water tube boiler, construction and working of water tube boiler. And what is the difference between fire tube and water tube that we studied? Then there are some parameter or phenomena which occur in the boiler unit, that is swell and shrink effect. So what is the causes for the swell and shrink? What are the effects because of the swell and shrink phenomena, and how to reduce that phenomena, that we studied. Then in the control scheme, we started with the parameters which is being controlled in the boiler unit. So these parameters are basically drum level, then combustion, pressure, steam temperature, and furnace draft control. Yesterday we studied drum level control. So boiler drum level control is, there are three different ways, not three ways, we can say these are the three scheme by which you can control the boiler drum level. So single unit, two unit, a single element, two element, and three element are used accordingly. This is the diagram for the single element drum level control, where you can see only one variable is measured and the boiler drum level is controlled. In the next, you will see two element drum level control, where level as well as the feed water flow is measured and boiler drum level is controlled. That's why it is called as two element. In the three element, drum level, feed water flow, and steam flow, all these three variables are measured and the boiler drum level is controlled. That's why it is called as three element drum level control. So as the demand is considered by using the steam flow measurement, this control scheme, that is three element drum level control scheme, is beneficial to reduce shrink and swell effect, because it is related with the load change only, and this scheme is also considering the load changes, and that's why three element drum level control is the efficient one to reduce the effect of shrink and swell. Today we are going to start with the second control, that is the combustion control. So first we will study what do you mean by combustion. Then combustion control करना है मतलब exactly क्या control करना है, right? It is related with the efficiency of the boiler. So we are going to control the efficiency of the combustion. So efficiency depend on which parameter, how to control the efficiency so that we can achieve the combustion control, and how it will increase the efficiency of the boiler. That relation we are going to study today. Okay, combustion. Everyone knows combustion. It is a simple phenomena where combination of oxygen with some fuel element, and at particular temperature the spark is carried out, flame is produced. That process is called combustion. So we can define it as combination of oxygen with other element takes place rapidly with the release of heat. This reaction is called combustion. What elements we required for the combustion? Three basic elements. What are those? Sufficient quantity of oxygen, fuel, kindling or ignition temperature. Here we are saying proper quantity of oxygen. Why? Because if the oxygen is less, even if the fuel is available, ignition temperature is there, but still you will not able to ignite the fuel, right? So oxygen is must, sufficient quantity is required. For example, 7th या 8th में experiment किया है, if the candle is there and it is ignited, you can see the flame, but if the glass is kept on the candle, suddenly the flame extinguish, right? So why this is so? Because there is a less quantity of oxygen when you are putting the glass on the flame or candle, oxygen supply is reduced, and that's why the flame extinguish. So we require sufficient quantity of oxygen to produce the combustion, to produce the flame. Fuel. Now fuel means what? It may be liquid, it may be solid, it may be gas, the thing which can be ignited by using a ignition temperature is called fuel. So fuel may be coal, it may be kerosene, it may be petrol, or gas, you can say butane gas, LPG. So different fuels are there. So depending on the requirement, the type of fuel is used. Generally for the boiler, coal is used in the furnace to carry out the combustion. That is solid fuel. Then kindling or ignition temperature. Kindling or coal, I am talking about the large capacity boiler. For small capacity, different fuels are used. We will come back to it. Kindling or ignition temperature क्या है? Kindling temperature मतलब the temperature at which the spark can take place. Okay? So that temperature is called as ignition temperature or kindling temperature. For example, in our house also, even if we turn on the burner, sufficient oxygen is available. Now you turn on the burner, so LPG gas is coming out, so fuel is available, but still you cannot see the flame. I'm not talking about the automatic ignition gases. I'm talking about our normal ordinary shading, where you need lighter to produce the spark, right? So even if the fuel available, oxygen is available, but still you will not see the flame unless and until it will get the ignition temperature. So we are using lighter, and what is done? The spark is produced, that is the ignition temperature is created so that you can see the flame over there. There is a combination of the air with fuel, that is oxygen with fuel, and with ignition temperature it can produce the flame. So heat is generated. So these are the basic elements which are required. In this triangle also, combustion triangle, you will see oxygen, fuel, and it will produce the heat. So this is called as combustion triangle. Then we will talk about boiler efficiency. Why? Because we need to control the combustion. तो combustion control करना है मतलब exactly क्या control करना है? Level, pressure, temperature तो समझ में आता है, right? Because these are the variables. But combustion is not a variable. So if you want to control the combustion, what exactly our objective is? So it is, we are going to relate the combustion process with the boiler efficiency. What do you mean by efficiency? Boiler efficiency simply relates energy output to energy input, usually in percentage term. In general, efficiency of the unit means what? When we are talking about the efficiency of heat exchanger or efficiency of any other unit operation, what do you mean by that? Yes, please. I'm asking about the efficiency. Forget about boiler. Efficiency term का meaning क्या है?
Output divided by input.
Output by input. Okay, what it should be? What it should be? When you will
In
say,
which,
when you will say it is highly efficient?
for low input we get more output.
For low
For less
input,
input.
Okay.
For less input, we get more output.
Okay. See, efficiency, for example, if I am saying my lecture is efficient, what does it mean? What I am teaching, what I am talking, each and every word you are getting. Okay, the knowledge gain is there because of my lecture. Then I am saying the lecture is effective, efficient rather, right? So, output by input, that ratio we are taking, that ratio must be 1, then in boiler case I'm talking about, that ratio must be 1, then we are saying efficiency is high. So output by input. Now in the combustion, output क्या होगा और input क्या होगा? For the combustion process, what is the output?
Heat,
Heat export.
Correct. And input?
oxygen and fuel.
Correct. Oxygen and fuel. Okay. What about the others? Why you are not turning on your mic and giving the answers? Okay. अल्लाह मोरे पे ही क्यों इतना प्रेशर डालना है हर बार आंसर देने का? What about the others? I am asking just basic questions. Okay. So efficiency में output by input. In case of combustion, heat is the output, and what is the utility required to generate the heat? That are the inputs. So in the case we require fuel and air, right? But air, we are not purchasing the air from anywhere. It is available in sufficient quantity in the atmosphere, so we are using air. So we will talk about in terms of fuel, okay, because it is going to affect the efficiency. So output is heat and input is how much fuel is required to generate that heat. Okay. So here we will see boiler efficiency. Look at the screen. Formula. Boiler efficiency. So heat exposed in steam upon heat provided by the fuel multiplied by 100 to get the percentage term. So efficiency is output by input. Here we are saying output is steam, and that is heat exposed by the steam, and the input is heat provided by the fuel. Okay? Multiply by 100. So remember this formula. Now heat exported in the steam. This is calculated using the steam table from the knowledge of feed water temperature, pressure at which the steam is exported, and the steam flow rate. We will, जब हम control scheme start करेंगे, I will discuss these 3 points. Then heat provided by the fuel is in calorific value. Objective of combustion process is to achieve maximum efficiency. In simple word, हमें combustion control करना है, हमें maximum efficiency using combustion process वो achieve करना है. So combustion efficiency depends on which factor? So combustion efficiency means what? Complete combustion. If there is a mixing of oxygen and fuel, and that input is fully utilized to produce the heat, then we are saying complete combustion is there, and it will increase the efficiency of the boiler. So I will read this first point. Perfect combustion implies the chemical association of fuel and oxygen in exact amount. Any deviation from perfect combustion reduces efficiency, right? Output by input, 100% आउटपुट चाहिए, उसमें इनपुट भी पूरा यूटिलाइज होना चाहिए. Okay, मतलब optimum quantity of input, if it is fully utilized to produce 100% output, it is highly efficient. So here fuel and oxygen is mixed in exact quantity and the combustion is carried out, then we are saying it is a perfect combustion and it increases the efficiency. Any deviation from perfect combustion reduces efficiency. What does it mean? Suppose आपने coal and oxygen लिया है and coal some after combustion process also some coal is left unburned. Okay, So remains of coal are there on that grate or tray, combustion tray. तो क्या होगा? It means the fuel is not completely utilized to produce the heat, so it is incomplete combustion. And incomplete combustion reduces efficiency. Why? Because the money is wasted in the fuel and that fuel is not fully utilized to produce the heat. So our objective is to carry out complete combustion, because complete combustion is related with the efficiency. If it is complete combustion, we are saying it is highly efficient. Okay. Now, what are the factors which are affecting combustion efficiency? That we will study. There are 4 factors which are affecting combustion efficiency. सबको combustion efficiency समझ में आया है? Is there
Yes,
any
ma'am.
doubt? Okay.
No,
किसी
ma'am.
को कुछ doubt नहीं है? Should I go ahead?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
तो फैक्टर्स क्या है वो हम स्टडी करेंगे. कंबशन इफिशिएंसी मतलब क्या है? कंप्लीट कंबशन. तो फैक्टर्स कौन से हैं कि जो कंप्लीट कंबशन के लिए रेजिस्ट करते हैं? सो दीज आर द 4 फैक्टर. फर्स्ट इज एडेक्वेट मिक्स, सेकंड इज ज्योमेट्री ऑफ कंबशन चेंबर, थर्ड इज डाइल्यूशन एंड फोर्थ इज प्रोडक्शन ऑफ वाटर. सी कॉम्प्लिकेटेड टॉपिक है, थोड़ा कॉन्सेंट्रेट करो. Easily you will get everything in the lecture itself. So adequate mix, geometry of combustion chamber, dilution and production of water. यहाँ पे red mark किया है letters. So these are the 4 factors which are affecting combustion efficiency. We will see one by one. Adequate mix. The major factor in combustion efficiency is adequate mix. Each molecule of fuel is mixed with exact number of molecule of oxygen. If it is there, we are saying adequate mix is there, adequate mixture is there. So whatever fuel and air or oxygen we are considering for combustion process, they must be mixed adequately. There should be a molecule to molecule mixing should be there, so that it help in complete combustion. अगर proper mixing ही नहीं हुआ है, for example, if solid fuel is taken but only the surface is in contact with the oxygen and only the surface coal particles are taking into combustion process, but bottom में जो coal का layers है वहाँ पे oxygen ना होने की वजह से they are not taking part into combustion, right? So there is not a proper mixing. So what we require, proper mixing of air and fuel before the flame ignites or before the flame takes place in the furnace. So adequate mixture must be available. Second, geometry, if it is not there, incomplete combustion. Geometry of combustion chamber. In the construction sketch we studied the parts. वहाँ पे हमने देखा था combustion chamber या fire box. If you remember the geometry of that combustion chamber, यहाँ पे देखो, this is a fire box. Okay, you will see the dome shaped structure is there, then the grate, that is the platform is there where fuel and air mixture is taken and then the flame is produced. Hot gases are generated and they are accumulated in this structure. Okay, and this is also a part of combustion chamber which is attached to this firebox. So this complete structure is called as combustion chamber. So geometry of this combustion chamber is such a that it will provide enough space for the proper mixing of the air and fuel. It will provide enough space for accumulation of the hot gases, then carry out that hot gases through the combustion tubes, tube-like structure which is attached to that combustion chamber. Then the geometry should be such that यहाँ पे it is dome shaped, so that whatever the unburnt particle of the fuel which stuck to the wall of this firebox automatically will fall down on the grate and will take part in the combustion process again. जो कुछ यहाँ पे unburnt particle फ्लेम के साथ ऊपर जाएंगे, वॉल को स्टक हो जाएगा and automatically they will fall back and fall on the grate where the flame or combustion is carried out. तो जो unburned particle है वो भी वापस combustion process में part लेंगे. So it will help in the combustion process. Okay. Geometry of combustion chamber matters for the complete combustion. If proper geometry is not there, if the proper space is not provided, there are chances of incomplete combustion which will affect the efficiency of the combustion and ultimately it will affect the efficiency of boiler. Okay. Third is dilution. Dilution, as the air and fuel mixture is considered, okay, for the combustion process, but out of as we know, air is a mixture of 21% oxygen and 79% inert gases, mostly the nitrogen gas 78% and 1% other inert gases are there, right? So out of this, only and only oxygen is utilized in the combustion process, not the other gases. So 21% oxygen is utilized, but 79% nitrogen with other gas is not required. But still we cannot separate the oxygen from the inert gas and then only the oxygen is provided. For that obviously we are going to add the some unit in the not unit, we are going to add some scheme so that what amount of air is required, only that amount of air is being sent. ऐसा नहीं है कि एटमॉस्फेयर में एयर फ्रीली अवेलेबल है तो एयर क्वांटिटी कंटिन्यूअसली मतलब सप्लाई ऑन है एंड फ्यूल को लिमिट करना है. नो, वी हैव टू लिमिट एयर एज वेल. व्हाई? Because as I said, if you consider 1% or one molecule of air, in that also only 21% of that molecule structure is utilized because oxygen is there and the other is not utilized in the combustion, and the presence of nitrogen reduces the temperature. So it is not helping in the combustion, but it is reducing the temperature or the heat produced in the combustion chamber. So excess amount of air is not required or it is not advisable, because if the excess air is available, oxygen is utilized, but the inert gas, that is nitrogen gas percentage is more, and because of that the temperature reduction is there. That factor is called as dilution. I will read this point. Dilution: air is a mixture of about 21% of oxygen and 79% of inert gases with varying percentage of water vapor. Nitrogen do not cause or participate in reaction, but presence lowers the temperature. Yes, Chetan? Okay. So this is called dilution. We don't want excess amount of air for the combustion process. Okay. Next is production of water. It results from the combustion of hydrogen and oxygen. Air contain this other gases, 1% other gases, उसमें hydrogen present रहता है थोड़ा सा. Oxygen is already there in the air. So this hydrogen and oxygen mix with each other and produce some water droplets. Okay, so it produces water. If the flame is not there, unnecessarily moisture content are produced in the combustion chamber, and obviously it reduces the efficiency of combustion. So we don't want the excess air. Dilution and production of water के लिए क्या है? Excess air limit करना है. Okay, so these are the factors which are affecting combustion efficiency. Combustion efficiency depend on complete combustion. Complete combustion means there should not be any unburned particle after the combustion process. Complete utilization of the utility to produce the heat. So that is called as highly efficient. So combustion efficiency should be high. To make it high, we need to monitor or control this factor, that there should be adequate mixing, there should be proper geometry of the combustion chamber, dilution should be avoided. For that, excess air should not be there in the combustion chamber, production of water should be avoided, so that excess air should not be there in the combustion chamber. Okay, any doubt in this?
मैम जरा लास्ट पॉइंट प्रोडक्शन ऑफ वाटर जरा समझ लो.
Production of water का है, hydrogen and oxygen gas mix with each other, so H plus O2, what it is giving? H2O, right? So water droplets are produced, not when the flame is produced, but suppose ignition temperature is not there, only the air and fuel mixture is added in the combustion chamber. So air and fuel mixture है, air में hydrogen and oxygen present है, वो कंबाइन होके मॉइस्चर क्रिएट होता है, एंड मॉइस्चर से बाद में अगर फ्लेम प्रोड्यूस होने के बाद भी अगर इंटरनल कंबशन चेम्बर टेम्परेचर इज लोअर, इट इज रिड्यूसिंग द अफेक्ट efficiency, right? So that factor is also considered. It is very minor, but still it is considered. Got it?
पण टेम्परेचर कमी असल्यावर काय होतं का?
टेम्परेचर जर सी कंबशन, फॉर एक्झाम्पल जर तुम्ही बर्फाच्या ठिकाणी गेलात आणि बर्फाच्या ठिकाणी तुम्ही एखादं इग्नाइट करायचं ठरवलं, तर यू आर टेकिंग लॉट ऑफ एफर्ट्स टू इग्नाइट द सेम एअर अँड फ्युएल मिक्सचर, राईट? बट सेम एअर अँड फ्युएल मिक्सचर जर तुम्ही नॉर्मल ॲटमॉस्फिअरिक टेम्परेचरला, सपोज 30-40 डिग्री जे टेम्परेचर आहे, त्या टेम्परेचरला जर तुम्ही इग्नाइट करायला गेलं तर इट इज मोर इझी दॅन टू इग्नाइट ॲट द कोल्ड प्लेसेस. ओके, सो it means what? The outside temperature matters for the ignition of the air and fuel mixture. Okay, so if the ignition is not there, if the flame is not produced, but even if the air and fuel mixture present and the moisture is deposited in that area, obviously you have to increase the ignition temperature to carry out this flame over there. Okay, so it is affecting the heat produced. Got it?
Yes.
This is very minor, but still, as we are considering the boiler efficiency and it is affecting the efficiency, this factor is taken into consideration. And that's why analyzers are there which will analyze the different percentage, different, what we can say, whatever the unburned flue gases are exhausted to the atmosphere. So analyzer analyze that unburnt flue gases also. If the percentage is more, the flame is carried out and they are cleaned over there. मैंने लास्ट टाइम आपको बताया था, इंडस्ट्री का ये जो ठाणे बेलापुर रोड है, अगर वहां से आप हाईवे से आते हो तो चिमनी के ऊपर फ्लेम बर्निंग दिखता है. ओके, तो आपको फ्लेम क्यों दिख रहा है वहां पे? बिकॉज दैट ट्रीटमेंट ऑफ द गैसेस आर देयर. गैसेस में क्या प्रेजेंट है? ऑक्सीजन एंड हाइड्रोजन प्रेजेंट है. ऑक्सीजन प्रेजेंट है, हाइड्रोजन एंड सम अदर पोल्यूटेंट गैसेस आर ऑल्सो प्रेजेंट. ओके, तो उसके ट्रीटमेंट के लिए वहाँ पे फ्लेम प्रोड्यूस करके वो प्री ट्रीटेड किया जाता है. सो दे आर मेड पोल्यूशन फ्री एंड देन एग्जॉस्टेड. उसका यहाँ पे रिलेशन नहीं है, बट जस्ट आई एम टेलिंग द मिक्सचर ऑफ द गैसेस आर ऑल्सो कॉजिंग सम इफेक्ट. सो यहाँ पे आपने एयर एंड फ्यूल का मिक्सचर लिया है, लेकिन सपोज इग्निशन टेम्परेचर मेंटेन नहीं है, तो वो एयर एंड फ्यूल का मिक्सचर वहाँ पे रहेगा. हाइड्रोजन एंड ऑक्सीजन गैस रिएक्ट होके वहाँ पे मॉइस्चर डिपॉजिट होगा, and because of the deposition of the moisture, you need to increase the temperature in the combustion chamber to cause the flame over there. So unnecessarily it is adding in the input. Utility तो आपका बढ़ गया ना, efficiency आपका उस वजह से affect हो गया. So this factor is considered. Got it? Alak sir. Yes, understood?
Yes, ma'am.
Yes, ma'am.
Allah sir, your doubt is clear. Are you there? Next is objective of combustion control. So what we studied, combustion efficiency क्या है, factors क्या affect करते हैं. Now the next thing is combustion control करना है तो उसके objective क्या है. First is control the rate of firing. Second, combustion efficiency control, and third, safety control. Control the rate of firing. Combustion किस चीज पे डिपेंड है? How much air and fuel is added to the combustion chamber, right? So we need to control the rate of firing. For that we need to control the air and fuel flow. So how much air and how much fuel we added in the combustion chamber control the rate of firing. So first objective is to control the rate of firing. Second objective is control the combustion efficiency. Just now we studied the combustion efficiency. So if you want to control the combustion efficiency, we need to take that 4 factor into consideration and apply the control scheme. To maintain the balance using maximum amount of fuel to air ratio, which is known as combustion efficiency. And third is safety. What we want control the rate of firing, control the efficiency, but in doing so, in obtaining the above two objective, we need to take care for the safety, because combustion furnace where very high temperature, pressure are there. So hazard risk is more in such area. So we need to provide some interlocks to provide the safety. So objectives of combustion control: control the rate of firing, combustion efficiency control, and safety control. Remember this. Then combustion control scheme. How to control the combustion? There are 4 types of combustion control scheme. Type 1, Type 2, Type 3, and Type 4. Type 1 is parallel adjusted positioning with no metering. Type 2 is parallel adjusted with full metering of air and fuel. Type 3 is parallel adjusted full metering with fuel limiting, and type 4 is oxygen trim control. So here type 1, type 2, type 3 and type 4, ये चारों control scheme जो है, these control scheme are used to obtain the objective. What is our objective? To control the combustion. Combustion control करना है मतलब क्या करना है? 3 objective control करने हैं. Rate of firing control करना है, combustion efficiency control करना है, और safety control करना है. Right? So to achieve these 3 objective of combustion control, we are using these 4 different control scheme. Not at a time, but as per requirement, the particular one is applied. Okay, we will go one by one. We will go for type 1, parallel adjusted positioning with no metering. Read the name twice or thrice. Parallel adjusted positioning with no metering. इसमें क्या समझ में आता है? कुछ तो पैरेलली एडजस्ट किया है, कुछ पोजीशनिंग यूनिट जो है वो पैरेलली एडजस्ट किया है. नो मीटरिंग का मतलब क्या है? विदाउट मेजरमेंट. ओके, so parallel adjusted positioning with no metering. Look at the diagram. So in this diagram, basically parts पे बता देती हूँ diagram में क्या indicate किया है. This is the furnace or combustion chamber where the flame is carried out. This is the combustion chamber where flame is carried out. Now to carry out the flame, what are the utilities? What we require? Fuel and air. So this is the fuel line. Okay. This is the fuel line which supply the fuel to the combustion chamber. This is the air line. So this air line is used to carry out the air towards the furnace or combustion chamber. So this fuel and air line are connected with the combustion chamber. Now, this is fuel control valve. This particular valve which is installed in the fuel supply line is the fuel supply valve. It is pneumatic valve with positioner. This valve is called as a damper, and you will see this valve is installed in the air supply line. Instead of pneumatic control valve like this valve body, dampers are preferred for the gases or air lines. Okay. Both the valves are operated by using this signal, and this signal is from the loop. Now we will see what is the relation. Here this is the steam generated from the boiler. ओके तो ये सिर्फ नीचे का पार्ट दिखाया है कंबशन चेम्बर, एंड जो बॉयलर से स्टीम आउटलाइन है वो यहाँ पे दिखाया है. सो दिस इज द स्टीम dispatch line. Steam is produced from the boiler and that is indicated through this line over here. Now air and fuel is sent to the combustion chamber depending on the demand. If the steam demand is more amount of heat to be produced in the combustion chamber. To produce more amount of heat, more amount of fuel and air must be supplied to the combustion chamber to match with the increase in the demand. That's why we are measuring steam flow. Inferential measurement is there. Steam का flow नहीं measure किया जाता है, pressure measure किया जाता है, but it is to monitor the steam line flow. So here you will see PT101. PT is pressure transmitter which will monitor the steam flow and indicate it to the pressure controller. This is PIC, pressure indicator controller. So the signal which measure the steam line flow is given to the controller. Controller will generate the signal, and this signal is we can say the signal is splitted and given to the two control valve which are acting parallelly. This controller signal is adjusting the position of the valve of fuel and air in such a way that the fuel to air ratio is maintained. Okay, it's not like that कि ये 50% open हुआ तो ये भी 50% ही open होगा. Here fuel to air bias station is there or calculator is there. Okay, so this program will decide for this. Suppose controller output, controller if you say output is in the range of 3 to 15 psi, or if you say electrical signal it is 4 to 20 milliampere. So for lower range what should be the air quantity, or for higher range what should be the air quantity? That ratio is decided, and depending on that, positioning of the wall is done. So this calculator will decide for the controller output how much air to be added to the furnace. Okay, so this is a ratio station which will adjust fuel to air ratio. Here we are not measuring the fuel flow, we are not measuring the air flow. What we are doing, we are just adjusting the fuel and air control valve to change their flow rate depending on the steam demand. That's why it is called as parallel adjusted positioning without metering, or no metering is there. Okay, this is I just read this FPT PIC तो हो गया. FCV मतलब क्या है? Flow control valve. FC fail to close. Okay, this is also FCV. This is also flow control valve, but it is air flow control valve. uh, FY, this is a flow calculator, और trans Y का meaning क्या है? Transformation. Even if it is I to P converter, Fy is written. Even if there is some relay function, Fy is written. So Y का meaning है calculator, transformation, conversion. यहाँ पे उसका एक्चुअल फंक्शन क्या है वो इंडिकेट किया जाता है. यहाँ पे प्लस माइनस परसेंटेज लिखा है, मतलब ये इट इज फॉर द रेशियो, राइट? दैट्स व्हाई इट इज यूज्ड ओवर हियर. सपोज ये आई टू पी कन्वर्टर रहता तो यहाँ पे ब्रैकेट में I/P लिखते हैं. रिले रहता है तो रिले का साइन देते हैं. इफ इट इज एडर, एडिंग का साइन देते हैं. ओके, so this is considered as a converter, calculator, transformer, like this. Okay. Any doubt in this? कंट्रोल स्कीम में हमने क्या स्टडी
मैम
किया? हाँ बोलो.
मैम वो
Yes,
FY के लेफ्ट में क्या लिखा है? फ्यूल प्लस एयर, उसके नीचे
fuel slash air, that is fuel to air bias adjustment station. Okay.
ओके.
ये या ये सारे डायग्राम लिपटेक में है, बट आई डोंट नो लास्ट ईयर थोड़ा ये पीपीटी जब मैंने बनाया था तो आई दैट डायग्राम्स आर नॉट अवेलेबल, दैट्स व्हाई नोटबुक का कैप्चर करके लिया है. ओके, नॉट प्रॉपरली विजिबल. तो ये फ्यूअर टू एयर बायस एडजस्टमेंट स्टेशन. ठीक है, कुछ डाउट है? दीपावली, धीरज, दिव्या, संकेत, हेमांगी, इबाद,
No, ma'am.
others?
No, ma'am.
See,
No, ma'am.
if you concentrate here, it is very simple. लेकिन आप बुक से पढ़ने जाओगे सडनली तो कंफ्यूज हो जाओगे, because language is not so simple. I am just explaining in our own language, but you have to write the answer in the technical language only. For that, you need to refer the books. So parallel adjusted positioning with no metering. Here what we studied, fuel and air control valves are adjusted parallelly. Their position is adjusted by using the steam demand. So if the steam demand is more amount of fuel and air should be added to the furnace. For that, the valve position is adjusted by using the signal. If the steam demand is less, accordingly it will add the signal. But now tell me, here we want to check the streamline flow. If the flow is less, what does it mean? Relate it with demand or supply or pressure. If the pressure is less, it means relate it with demand. If the streamline pressure is less, it means
less demand,
less demand. लेस डिमांड नहीं रहेगा ना. इफ द स्टीमलाइन प्रेशर इज लेस, इट मींस मोर डिमांड. स्टीमलाइन में प्रेशर कब कम रहेगा। जब डिमांड ज़्यादा है, डिमांड कम है तो स्टीम लाइन में स्टीम पड़ा रहेगा, इसका मतलब है उधर प्रेशर ज़्यादा रहेगा, राइट? सो स्टीम line pressure is less, it means more demand. So let us take the example of more demand. If the demand is more, it means steam line pressure is less. That signal is given to PIC. PIC को कुछ set point दिया है. It will compare and give the output signal. If the demand is more, but PT का signal is less, right? So this control valve, fuel and air control valve, डिमांड ज्यादा है मतलब क्या एक्शन होना चाहिए फ्यूल एंड एयर कंट्रोल वाल्व का? बोलो जल्दी जल्दी, चलो, सिंपल क्वेश्चन आई एम आस्किंग। डिमांड ज्यादा है तो फ्यूल एंड एयर सप्लाई ज्यादा होना चाहिए या कम होना चाहिए?
ज्यादा होना चाहिए मैम।
ज्यादा होना चाहिए। ज्यादा
ज्यादा
होने के लिए कंट्रोल वाल्व का पोजीशन क्या होना चाहिए, ओपन और क्लोज?
Open.
ओपन होना चाहिए, राइट?
ओपन
ओपन होने के लिए कंट्रोलर का सिग्नल, ये जो आउटपुट सिग्नल है, इट मस्ट बी हाई, राइट? लेकिन इसको पीटी तो इनपुट लो दे रहा है, बट कंट्रोलर आउटपुट वी आर एक्सपेक्टिंग हाई। पीटी क्या कर रहा है? पीटी क्या है? इफ द डिमांड इज मोर, स्ट्रीमलाइन प्रेशर इज लेस, दैट इट इज मेजरिंग एंड गिविंग द सिग्नल टू कंट्रोलर, बट कंट्रोलर का आउटपुट मस्ट बी हाई. So for less input, controller must give high output. So what you will call controller कैसा होना चाहिए आपका डिजाइनिंग में?
रिवर्स एक्शन.
Reverse acting, correct. So in the designing, you have to select reverse acting controller. If the input is less, high output is expected. If the demand is less, डिमांड लेस है मतलब यहाँ पे स्ट्रीमलाइन प्रेशर ज्यादा रहेगा। स्ट्रीमलाइन आपका प्रेशर ट्रांसमीटर मोर सिग्नल, सी द सिग्नल इज हाई फॉर द हाई सिग्नल, बट इफ द डिमांड इज लेस, उसके लिए आपका पीटी हाई सिग्नल दे रहा है। डिमांड लेस है तो फ्यूल एंड एयर वॉल्व क्लोज होने चाहिए। वी डोंट वांट मोर क्वांटिटी ऑफ फ्यूल एंड एयर। डिमांड ही नहीं है तो स्टीम प्रोडक्शन कम होगा। स्टीम प्रोडक्शन कम है तो हॉट गैसेस जनरेट करके क्या करना है, राइट? So we have to think about the efficiency. For efficiency, we have to supply only required quantity of fuel and air. So if the demand is less, less fuel and air should be added in the furnace. But if the demand is less, your pressure transmitter providing high signal to the controller. But in that case, your controller should provide lower signal to the control valve for their positioning. For that, controller must be reverse acting. और your अगर कंट्रोलर रिवर्स एक्टिंग नहीं लिया तो सपोज कंट्रोलर रिवर्स एक्टिंग नहीं है, डायरेक्ट एक्टिंग ही है, तो आप क्या कर सकते हो?
वॉल एक्टिंग रिवर्स कर लेगा.
करेक्ट. If the controller is direct acting, you can make your control valve actuator as reverse acting. For higher signal, they will respond in opposite way. That is, they will close. For lower signal, it will open if it is air to open, air to close accordingly. So you have to design, you have to select the components in that way. Understood this, everyone? Is there any doubt?
मैम वो डायरेक्ट एक्टिंग और रिवर्स एक्टिंग का फिर से बताइए मैम।
ठीक है, डायरेक्ट एक्टिंग का कंसेप्ट क्या है? इफ द इनपुट इज लो, आउटपुट इज लो. इफ द इनपुट इज हाई, आउटपुट इज हाई, देन वी आर सेइंग द कंपोनेंट इज डायरेक्ट एक्टिंग. नाउ यहाँ पे कंडीशन क्या है वो समझ लो पहले. कंडीशन क्या है? आपका ये जो स्टीम है, स्टीम सप्लाई डिपेंड्स ऑन द डिमांड ऑफ द स्टीम. इफ द डिमांड इज मोर, steam supply is more. If the steam supply is more, pressure in the line is less. steam supply ज़्यादा है मतलब लाइन प्रेशर कम है. लाइन प्रेशर कम है, लेकिन अगर steam डिमांड ज़्यादा है तो यहाँ पे आपका रिक्वायरमेंट क्या है? more fuel and air should be supplied to the furnace. मतलब डिमांड ज्यादा के लिए वॉल शुड बी ओपन मोर. तो वॉल अगर ज्यादा आपको ओपन करने हैं तो मतलब इसको एक्चुएटिंग सिग्नल उस प्रोपोर्शनेट में देना चाहिए. इफ आई वांट दिस वॉल टू बी ओपन इट शुड गेट द एक्चुएटिंग सिग्नल इन दैट वे, राइट. बट यहाँ पे क्या हम मेजर कर रहे हैं? स्टीम लाइन प्रेशर मेजर कर रहे हैं, जो कि डिमांड के साथ रिवर्स एक्शन है. डिमांड अगर ज्यादा है, स्टीम लाइन प्रेशर कम है. स्टीम लाइन प्रेशर ट्रांसमीटर क्या करेगा? लोअर सिग्नल इट विल गिव टू द कंट्रोलर. सेट पॉइंट से कंपेयर करने के बाद एयर मोर आएगा तो कंट्रोलर का आउटपुट होगा. बट फॉर लोअर सिग्नल यू आर गेटिंग द आउटपुट लोअर आउटपुट. तो लोअर आउटपुट के लिए वॉल लो ओपन होगा तो फ्यूल एंड एयर सप्लाई इज रिड्यूस्ड. बट व्हाट एग्जैक्टली वी वांट? इट शुड बी इंक्रीज. तो उसके लिए आपको ये रिवर्स एक्टिंग करना पड़ेगा. मतलब for less input controller should give high output, then only it will work. और अगर ये रिवर्स एक्टिंग नहीं लिया, ये डायरेक्ट एक्टिंग ही है कि इसको लो इनपुट दिया तो इसने लो आउटपुट दिया. लेकिन अगर आपका कंट्रोल वॉल एक्चुएटर रिवर्स एक्टिंग है तो लो इनपुट के लिए ये ज्यादा ओपन होगा, राइट. सो either this must be reverse acting or this must be reverse acting, then it will satisfy the condition. Understood now? समझा है?
Yes, ma'am. Yes, ma'am.
Okay. Please do one thing. From the next lecture, अभी भी मैंने पहले भी बोला है, but I know very few are doing so. Please each and everyone start with your notebook and pen. ये जो है ना, ये सब sequentially है. सडनली अगर मैं आपको कुछ बताती हूँ ना तो वो आपको नहीं समझ में आएगा. ये बढ़ता है तो ये कम होता है, ये कम होता है तो उसका एक्शन क्या होता है, उसका इफेक्ट क्या होता है. तो एरो डायरेक्शन में फॉर एग्जांपल स्टीम लाइन प्रेशर इंक्रीजेस, पीटी का सिग्नल डिक्रीजेस, कंट्रोलर आउटपुट शुड इंक्रीज. ऐसा आप शॉर्ट में लिखते जाओ. बिकॉज बुक में भी आप पढ़ोगे ना तो आपको पैराग्राफ्स है, उसमें आपको लाइन टू लाइन फुल कंसंट्रेशन करके पढ़ना पड़ेगा. देन यू विल गेट. बट इफ इन द लेक्चर यू मेक योर ओन नोट, it will be beneficial for you to understand the logic. Forget about the marks. मार्क्स आपको मिल जाएंगे, उसमें डाउट ही नहीं है. इतना अच्छा सिखा रही हूँ कि आपको सारा समझ में आएगा. बट you have to remember it for lifetime, because these are the unit operation which are used in each and every process industry. You have to work on that, you have to design it, you have to control it. Even if you are in the software industry and you are making some programs for the industries, factories, what are available in the factory? These units only. कौन सा भी फैक्ट्री आप ले लो, तो आपको इसका नॉलेज बहुत इम्पोर्टेंट है, राइट. सो प्लीज make sure you are comfortable with the lecture with your own way by writing your own notes. So this is parallel adjusted positioning with no metering, type 2, 3, 4. Tomorrow we will study. For today, let us stop over here. Is there any doubt in the lecture? स्पीड ज़्यादा स्लो है, वॉल्यूम कम है, वॉल्यूम ज़्यादा है, जनरल भी है तो आप फीडबैक देते जाओ. बोलो. I will download that.
Nothing, ma'am.
आपने कुछ नहीं बोला तो I will guess कि you are getting everything what I am teaching over here, and I will expect the same thing in the oral Viva exam from you people.
Hello, Poonam ma'am.
हाँ बोला.
Ma'am, I did my fee payment and I also filled my Google Forms. How can I get my verification that my fees is paid and
Okay. Just ping me on the WhatsApp and send me. You already paid the fees.
Yes, ma'am. I paid the fees.
Okay,
I can
just
send you the copy of
yeah,
transaction.
yes. Send it to me. I will check it in the office with the Mahadik sir and let you know. Okay.
Okay, sure, ma'am. Thank you so much.